Can you see our slides?
Yes.
Yeah. Thank you.
I was looking for a slide like this. Wow, nice, very nice. Yes.
So it's time. So we would like to start Tcahn International third edition. Today we go to Sweden. And today's MC is Sarasan from Nagoya University, Agriculture Department. Please start, Sarasan.
Good day, everyone. So today we are diving into a global exploration with Tcahn International here. So let's discover what makes Sweden out of most intriguing countries in the world with its culture and its startup ecosystems. Now,
Previous?
yes. So here we have Sweden in its all glory on the map. As we can see, it has a long coastline, and it's also in between Norway and Finland, and known for its long coastline and iconic Viking history, and its snowy weathers. This is the land of innovation, you guys. And yes, it's the place of furniture assembly challenges like courtesy to IKEA. Now, let's see the magic of Sweden. Now, at the top left, we can see that the Swedish people are embracing the cold culture with style. And in the middle picture, we can see the folk costumes of Sweden, the traditional costumes. And you can see they are really pretty. On the top right, we can see the Swedish meatballs, which IKEA made famous globally. At the bottom, we can see fika culture. It's really amazing culture for the Swedish people, where they take a break, grab a bun, and enjoy the coffee. In the middle picture at the bottom, we can see Stockholm, which is said to be the most beautiful city in the world. And it's also known as the Noble City, where annually Nobel Prize is held in the Stockholm halls. And at the bottom, we can see the Ice Hotel, talking about a cool place to stay, huh? Next slide, please. In this slide, we can see some famous Swedish companies. Some of us know most of them, and the others are soon to be unicorns. So we have on the right, the unicorn companies, and on the left, the Sunicorns. And everybody knows Spotify. And then we have also Klarna, which is fintech company that make buy now, pay later possible for poor people like us. And we have Cry, which is telemedicine company that is offering online consultation with doctors, and also it gives mental support all 24 hours. And also we have Northvolt, which is a company that manufactures lithium-ion batteries for electric cars. On the next slide, we will see my favorite is King, which produced Candy Crush game. I spent most of my life playing this game. And next, I want to talk about the Swedish startup ecosystem. What makes this country so special, and how does it actually annually contribute to many startup companies? At first, it has strong global presence. It ranked one of the leading countries for the startups, especially in terms of unicorns, and Stockholm producing the second highest number of unicorns per capita globally. It's just after Silicon Valley. And also the government support and innovation hubs, and also the availability of funding makes it really good country to start up business, where you can find support and funding. And also in Sweden, you have access to talents and high digital literacy, because the Swedish people are really highly educated and tech savvy. They also have really high English proficiency, and making them attractive country to start up and international companies. And then also they focus on sustainability and green tech, because the Sweden startups are often pioneers in the sustainability and aligning with their country's strong environmental policies. and clean technology, renewable energy, and sustainable practices. And also they have collaboration ecosystem where you can collaborate with other companies. They can give you advices. They are called to be a closed net. So you have access to working spaces, accelerators, and incubators. And then also they have strong focus on technology and innovation, where Swedish startup often focus on tech-driven industries. They have Skype, they have Monjang. It's the creator of Minecraft. Then finally, the work-life balance in Swedish ecosystem is really great. And people like to focus on their life too, besides their work. That makes them healthy, makes them happy, and makes their work even better. So that's all for my Sweden introduction. And now let me introduce Dr. Swagata for you guys. She is a designated assistant professor at our university, and she co-funded Serial X AB with her professors during her postdoctoral research in the University of Gothenburg. So today, Dr. Swagata will talk to us about her experience and how her company does their work. So thank you so much for joining us, Dr. Swagata.
Thank you.
Thank you, Sarah, for the amazing introduction.
Thank you.
The introduction to Sweden as well was very exciting and thrilling for me. I mean, because it brings a lot of memories back, and it's absolutely the same things that you have said that I experienced, including the fika culture to, I'm not so much into games, but except for that, everything what you said was so much ingrained in my memory, like for my fond memories.
I'm glad.
Yes, so it's great, and so I'm going to start talking so I don't take up so much time from everybody,
Okay.
So please let me know if you can see my screen, and if it is okay. It's visible
Yes.
and I'm audible.
Yes.
Okay, so yes, good afternoon, everybody. I can only see two people on the screen, but welcome to my talk. Thank you for your time. I am Swagata, and currently I am a designated assistant professor at the Department of Applied Physics in Nagoya University. And while I would like to talk about my journey, before I start the talk about the entrepreneurial experience that I have gained so far, it's because my startup venture started decently or recently, but decently after a lot of education has been already acquired. So I would like to emphasize more on how my journey from a researcher to an entrepreneur happened. But before that, there has been a lot of gain of knowledge and education that has happened, which means that I have studied a lot throughout my life, and it's mostly around natural sciences and with my majors in maths, physics, chemistry, and I did my master's in chemistry. I wanted to explore life sciences after I was almost getting bored with pure chemistry research. So I moved to Bangalore, India, and did my PhD research in structural studies on protein. So basically, the idea is to be able to understand protein structure. And this is where my journey to look at molecular structures started. I imagine most of the people in the audience may not be knowing very details about proteins and protein structure, but I will try to make it simpler as we proceed with different slides. And as a part of PhD, which is a very tedious time and very tiring time, I tried to switch to industry for a short time. And my first industry experience was actually in a startup, which was also based in Bangalore, India, which was making biodegradable products from seaweed extracts. And this was something very interesting because the company that I started working for were included the people of my age group. I mean, it was a group of people who graduated kind of together and trying to learn how to actually build a startup. So I would say before my actual journey of my startup started, I kind of had an environment where I already worked with startup culture and people who have started their own startup, and it has helped me to gain perspective. And then after my journey in India, my educational journey, I moved to Sweden for a postdoctoral research, and my research remained same as my PhD, where I was studying protein structures. And it was a little ahead of the technology that I was already studying back in India. As Sarah mentioned, Sweden is very technologically advanced also in terms of many natural science research. They have been doing very great, especially structural biology and X-ray physics are very much, there is a hub in Sweden, and most of the good research in structural biology of protein kind of started in Swedish universities in Stockholm and Uppsala. So it was a great place to start my postdoctoral journey, where I studied protein mechanisms, and then I ventured into startup. And after a few years of my postdoctoral and research experience and startup experience, I moved to Nagoya University for an assistant professor position. So in this lecture, I'm going to talk about this phase of my life. Okay. So the title of my talk is My Journey from a Scientific Lab to Co-founding My First Company. And the company is called CerealX. We will talk about why CerealX is called CerealX, but we need to go a few steps behind to understand what I do in my research and how I stumbled upon this venture. So fantastic. Sweden is a beautiful country and it has a lot of nice things, but it comes with a lot of cold and dark weather. So embrace yourself. So where it all began is my studies is basically about molecular structures of protein. So I study protein structures. And what is protein? What are proteins? Proteins are basically are the very important, crucial molecules that run almost every function in the body. You find proteins everywhere. They are basically running, they are the life building blocks of life. So you need to know about proteins. And while proteins are, you have different ways of studying proteins, I am interested in studying the molecular structure of proteins. So proteins do functions from sensing to, breathing, to transportation, to protection and immunity, to, controlling even glucose level in the body. So just 1 second, just move this. Yes. But protein structures, why do we need to study these kind of structures? Why do scientists keep making these proteins and understand the structures? The protein, sorry. Okay. So basically, protein structure solving is a huge and tedious process. It's a time-taking process. It's not very easy, but people do it anyway because it gives very high amount of valuable information. And this kind of information can be used to understand diseases better, and what kind of malfunctioning or mutation in a protein has caused a certain kind of disease or a certain kind of malfunctioning in the body. And then based on that information, we can design appropriate solutions to control that disease or prevent that disease or create treatment for curing the diseases. So protein structures are highly important in drug discovery. And with almost 120 years of protein research that has been happening in the past, there is always a lot of things associated with protein structure, and which is one of the Nobel Prizes that was given in this year, the Nobel Prize in Chemistry, that went to 3 scientists who worked on protein structures for their entire research life. And not only this, in addition to this, a lot of work on protein structures or overall macromolecular structures have received Nobel Prizes over the year, because the it has been very highly applicable in treatment of a lot of diseases and finding solutions. In fact, even if you talk about the pandemic that we went through in COVID in 2019 to 2022, a lot of information on drug designing and therapeutic designs came from information of the structure of the molecules and the proteins which which make the virus to create that kind of affect the human life. So now a lot of information on these protein structures which I am working with are experimental, but these experimental informations are now also used to create a lot of database, and many of the technologies are being developed to make it more automated through the use of machine learning and AI to be able to find cures faster. Going to my research, I'm an experimental biophysicist. I work with protein structures in the laboratory, holding tubes and bottles, pipette tips, and work on different proteins. Most of the protein structures that I have worked with are photoactive, which means they have light sensation. They get activated through in the presence of light, and many of them, yeah, have colors. Colors of the proteins usually come from binding to some ligands, cofactors, and chromophores. To solve protein structures is a very key step, because many of the technologies of solving protein structures are time taking, and based on what kind of technique you are using, you need to go to special laboratories. And in my case, I'm studying protein structure using this technology called X-ray crystallography, which means it uses a very high energy X-ray to take photographs or snapshots of crystals of the protein. And this X-ray is actually very important. It's not taking photograph of these crystals, it's taking photographs of the atoms of the crystals. So this energy that is basically in match with the atomic positions is equivalent to X-ray energy. And that's why X-ray crystallography is one of the very promising technology to study protein structures at atomistic and molecular level, at very detailed level. So, okay, so in this kind of technology, what we do is in the lab, we prepare protein samples. We use some technologies to purify these samples of molecules. We use certain buffers to make them appear and form crystals. And they are still in the solution but form like solid crystals. These crystals are taken to this very important laboratory, which is called X-ray radiation source, which is also called synchrotron. It has very high energy electron that is rotating across this whole big ring of the synchrotron, and that creates a very high X-ray that emerges out. And there are different laboratories, around 40 to 50 laboratories that are in this ring of synchrotron, out of which we use 1 or 2 laboratories to get the structure of the protein. So in this simple method, what we do is, it's a complicated method. In simplicity, what we do is we make these crystals, we take it to the synchrotron. Inside the synchrotron, we put this crystallized molecule to the X-ray beam, and we collect information in terms of dots or photographs or diffraction data, and we get the protein structure by using lots of softwares, programs, and mathematical algorithms that are available. Many of these things are automated. So in this X-ray crystallography technology, what is important is the method that is what we are using. So there are methods where I'm sorry, do you hear me well?
Yes.
Okay, thank you. So in the X-ray crystallography, there are majorly 2 kinds of methods which are very popular, and one of them uses these crystals to be frozen before taking to the synchrotron, and we call them conventional or cryogenic crystallography. Usually it was done with single crystal, and you can only get structure of one state of the protein, but you can try to get many different structures in different conditions and try to get an overall picture of the dynamics. Since it is done with single crystal, it's enough to get a full molecular structure. It is usually widely used method, and the methods that are used for single crystal study are very, very popularized over the last 40, 50 years. And they are require small data sets, and they are small in size in terms of the data that is generated. So most people prefer to use it. However, while this is in use, there is a new technology that I started working when I went to Sweden, which was an upgraded or advancement of this crystallography technology, where instead of collecting data from one crystal, we try to collect data from a series of multiple crystals that flow through the X-ray beam, which means each crystal give each frame, and these images are merged together to get the structure. And since many crystals are used in this situation, it's called serial method of crystallography. And multiple crystals are used, multiple data sets are collected, and data set is huge. However, the positive thing is, because we are collecting it from multiple crystals with a very high beam of X-ray, we can actually try to study a reaction before the crystal is completely damaged. So in this kind of technology, in brief, allows studying reaction kinetics in real time. But the data sets are complex, and it needs interpretation is complex, so less users are using it. However, what we wanted to do it is, we wanted more users to come to this advanced technology and try to study proteins in terms of the actual reactions that are happening. And to encourage something new, we have to provide them proper knowledge and service and information. So new researchers who are embarking into this kind of technology are prepared with what is available to them in this field. So it is very important to understand that there are not the technology also includes something which is called the sample measurements. And in this case, there are two kinds of primarily used sample measurements technique. One is using liquid jets, where it's like a nozzle where crystals flow through it, or something that uses a fixed support where crystals are actually embedded into a fixed support, and this support is moved, and you can collect data on that. However, there are several technologies of the flow technology that has been designed by experts in this field. And in both the cases, the biggest issue is there is not a standardized and commercialized tool for sample delivery. So what was the issue is, when we go for these experiments, the lack of standardized devices is a very big challenge. If a user wants to use something, that person is confused. What should I be starting and using? There is no actual particular optimized protocol available. Most of these techniques are built by expert users, means there are laboratories that are already very wealthy and has a lot of funding. And so they create their own kinds of technology. So many of them actually are just studied by or developed by special researchers, researchers specialized only in that technique. And when they build this technique for their laboratory, there are no commercially a standard thing available for the other people to use it. So if you want to use a technology, you must go to their lab, you must study the process with them, you should learn the technology. And this is very labor intensive, cost intensive, and I mean, it doesn't make sense that only a few sets of researchers are able to use the technology because of good funding. So what also happened is, during the COVID-19 pandemic, travel restrictions were there, and not many people can exchange these ideas and knowledge so easily, going and traveling to other laboratories. And there is a huge problem with researchers not try to shift their focus to do something different from pure research, which is trying to build and optimize things for commercialization. um, and and this is the thing which we think, that researchers have so much knowledge, but sometimes they do not have the way or support to translate that idea to help globally many of these other researchers. So what we thought, working when I was working as a postdoc, is how about we try to take some of these technologies and make them simpler, make them cost effective, which can be easily and conveniently used by a non-expert researcher, like a master's student or a PhD student who's just started using this kind of emerge into this research field. And then since they can have, and they can also build a set of small tools in their own lab, which is cheaper, so they can actually study these experiments themselves, and this kind of research become more popular. So that is the start of our venture into making usable, simple and usable technology. So we started with the logo saying, let's make some simple solutions to serial synchrotron crystallography. So where we make products for serial crystallography at synchrotrons. Now there are several synchrotrons in the world, and many more researchers actually use X-ray crystallography. So we would like to see if our technology is worth promoting. So let's try to see what could be our unique selling point that is not available till now. So one of the unique selling point of our product would be something that is compatible with a synchrotron machine, and machine having a head called goniometer. Okay, so let's go to what is goniometer. So here is a typical goniometer from a company Arinax, and this is basically the magnet, and this is where all the samples are positioned during X-ray crystallography data collection. So anything you have to solve a molecular structure, it is going to go, the sample is going to go to this place. And this is attached to a lot of other machineries, but when a user or a researcher go to a synchrotron with their samples, they target what should can go to this magnet. A typical magnet is about 9 to 10 millimeter in diameter. So, and there are different ways of aligning these in terms of, this is a base up uh, goniometer, this is a vertical kind of goniometer, this is a horizontal goniometer. The design of these magnets are more or less the same. And there are different techniques that are already available where they use a magnetic cap that exactly fits well with this goniometer magnet. However, these metallic caps are expensive and it may not be available with all researchers. And so we thought, okay, we should make a goniometer compatible cheaper device and generate a workflow, and researchers will get interested to use the thing since it is simple, economical, and user friendly. So we combined 3D printing technology and our expertise on what we knew about sample delivery to make a set of devices. Simply, we used your computer aided design, AutoCAD, to design a bunch of these uh, support systems. And we used 3D printer. It was a resin based 3D printer that we used for printing and washing and hardening the supports. And then we used a bunch of other hobby stuff, glue and double-sided tape and some other kinds of design. So this was all basically happening in the laboratory where we were trying to design prototypes of two kinds of devices. One was a flow cell, which is going to be an alternate to the flow technology, and one was a fixed target device, which is going to be a fixed target device. And after a lot of iterations on the prototypes, we had done a lot of iterations on the prototype, we came up with particular designs. So we wanted to verify the prototypes before we could actually say it is a very nice product. And as scientists, we have to go verify the prototype and do our scientific project. It should be able to work for our work first, and then we will see if we have customers. So we came up with a technology where we use the flow cell support to flow crystals from the support using a glass capillary, and a X-ray beam can hit the crystals from inside the glass capillary. These are all protein crystals, and we can collect diffraction data. So we went with this idea to a synchrotron, but before that we tested it in the laboratory ourselves to see if the flow is happening with a pump. Then we took it to a synchrotron, and our synchrotron was the Swedish synchrotron Max 4. It's a Max 4 synchrotron, where we have a particular crystallography beamline, where we tested with real crystals of protein, real experiments on the X-ray beam, and we got crystal structures, and we measured a lot of characteristics of the protein. We came up with a second idea of the fixed target device, which was about taking the sample from sample crystal preparation to the data collection without removing the crystals. So if there are many steps involved in crystal preparation, usually these are very sensitive and it can affect your sample. So what we decided is, let's take a bunch of already available plastic trays that are used for typical protein crystallization in all kinds of crystallography laboratory, protein laboratory, and try to design frames that will fit over these plates. And so you don't have to invest anything but on these plastic sheets. We came up with the idea where we designed uh, another design of this holder, which was a goniometer compatible holder, and that will hold this chip or the chip containing crystals, and we can collect data. So proof of principle is, we crystallized the protein, we saw beautiful protein crystals, we took them to a shipment device, we aligned it to the X-ray, and we collected several crystal structures. So we have now proven that both of these technologies are actually working, but these are still the prototypes. If we want to sell something, we have to make it marketable. So how to commercialize a product? And I will talk about my experience, purely my experience on how it all happened. So step one is form a team or build a team, which is a very crucial process, because in a team you need to have people who are aware with the field of research, which means that they can talk about challenges and promising future and prospects for this kind of technology. We need to have like-minded people and trustworthy people in the company, and which means you should be able to talk to each other without hesitation. And sometimes some research fails, which means you should be able to talk to people and correct it without really getting losing trust or losing your interest. You always have each other's back. I would say you can encourage and you will encourage each other. And then it is good to have a diverse set of strength in a company, where one person or two people are very good in advising, some people are good in taking care of finances, some have technical skills, some have social skills, some have marketing skills, which is a good thing. Interestingly, our team consisted of most of the researchers, with Lorna as one of the person who is a business coach and who knows how to build a company. And my other two colleagues, Per and Peter, were very good in technicality, means they knew how to build these 3D printed platforms and do small, big changes. I had the social skill, and Richard and Gisela with social skills have a lot of scientific knowledge about the field. So we built a company, and we built a team, and then we wanted to, yes, go for the next step, secure funding. While we are talking about company forming, we also want to have money, because we want to verify lab prototypes. We need to go to the synchrotron. We have to do strategize, and even some in every step there is a knowledge gain. And we want funding for a lot of different small parts of the work. So our funding was already, my postdoctoral funding was going on from the European Research Council. So they gave us little amount of funding to start and make proof of concept devices. We got help from GU Ventures, which is Gothenburg University Ventures. If Sarah spoke about the entrepreneurship and startup environment in Sweden, it is actually very good. And Gothenburg University Ventures is one of the very well doing venture companies that has incubated over more than 300 companies in the past years, 20 years that they have started. And they are supported by a lot of other funding bodies like European Union councils and Vinnova and many other funding bodies. And we also got funding from Vasa Angels, which is also a venture capital team, which I never met, but we were able to secure Vasa Angels funding from Gothenburg University Ventures. And so we have timely release of this funding to do different projects, which also means that even in a startup company, I had bits and pieces of learning process going on at each and every step. Then we wanted to give identity to a company. What is the company to be called, and why did we call Serial X? So basically, the Serial X company name comes from the the technology, which is serial crystallography. And the and crystallography is primarily done using high energy X-rays. And since high energy X-rays are generated in synchrotron, which are circular rings, so we came with the idea of making Serial X with a logo which looks like a synchrotron. So this was simple, and this was understandable. I mean, this was really interesting to know what it would mean if somebody says Serial X. So it's a serial crystallography technology, and with a logo that resembles what we do, what we want to do. And the tagline is finding solutions to serial crystallography. We also made a web page to promote our company and get orders if researchers are interested. We built the LinkedIn page, and we have also Instagram and X Twitter page for this, where we can sometimes we use it to communicate. So the idea is to give a presence to your company, which so it can reach out. And these days, I think it's quite easier to even have a focused company become very elaborate through digital marketing techniques. And this was something which happened quite well during the pandemic times, because everything was getting digital and more digital. So instead of people meeting with each other and having one-to-one meeting, many of the things were about content creation and making nice, cool looking things and promoting it through different kinds of social platforms. So I was building this web page and LinkedIn, so it can be promoted and people can look at the different kinds of progress that is going on. It's for keeping people interested. Then we also need to design products, because if you want to sell something, we have to design products. And one of the idea is product presentation is a very important aspect of selling something. Something that looks like a piece of plastic can be made into look like a fancy kit in by making a logo and making I these were the things I was doing in the laboratory while I was doing my postdoc research, is to how to try to make the product appearance look good. We came up with the idea of packaging and how inside of a box should look like, a prototype of a packaging box. We have made a lot of improvements over the time, and as you also see that mm, the logo has changed a little bit from previously, but the idea is to make these nice looking box and products uh, and and have some. So we also added some sort of keychains and mugs if the product order was higher, to make the users feel good, about buying from our company. So above a certain price, we would give them a free goodie or something. So it is a nice thing that we started, and we still keep doing it. And this is my way of what I learned about actually having a startup and starting from something that I have not done before to this. And we still continue to keep building communication via different social platforms. We keep reaching out to companies that would need them, these kind of products. Our major companies where these clients, the major clients are usually the pharma companies that are doing drug discovery research using protein crystallography, because some of these techniques are highly useful for setting up new protein crystals without any perturbation. You can collect, you need not ship the crystal from its plate. You can take the entire plate to the synchrotron. And we are now reducing our own manual effort by outsourcing. This is what is when you need funding to be able to try to outsource your design of your product and and pay the service company. So it's GU Ventures is actually helping us a lot about on this. And we are building communication materials so people can look into what the devices do, how they can be used for different kinds of techniques based on different kind of companies that would be using them. We keep changing and modifying these brochures, and if we are presenting also these in tech meetings and conferences that are based for drug discovery and protein research. And it is going on, and it will keep going on until we want to keep our company going on, which is, I think, good. My take home message are very interesting because I started my entrepreneurial journey after my PhD. And so I think that there is basically no age to become an entrepreneur, especially a biotech entrepreneur. You are interested, you want to do something different, and you have the resources, just do it. Always research about your technology and how it can be valuable and it can be made simpler. Don't make things complicated. People don't like complicated. Everybody likes simple stuff. And usually scientific experiments are usually high value experiments. So these kind of products, even if commercially available, are still cheaper to purchase for research labs. So don't worry so much about what kind of pricing. Usually you price it based on a given experiment that will take. So also research about competitions, research about your how you can make it much more valuable, to why you find it valuable and how it can be useful for others. If your technology is something very unique and you think you want to preserve it, always file an IP or a patent for the technology before you start making the products. With a prototype, just go for an IP filing and do some market research. So in our case, Gothenburg University helped us to do this market research if our product has any competition, and it didn't have absolutely any competition because most of these products were in-house lab mates with different researchers. Nobody tried to commercialize their products, and we came with this unique idea of goniometer compatibility, which kind of was very interesting for the scientific community. Start up fast. I mean, when you have an idea and you want to pitch a startup, start it up fast, but keep building it slow and steady, which means you really don't want to burn out in your journey of making a startup. Never build a startup without backing up finances, which I mean to say, don't be broke just to call yourself an entrepreneur. Always have a source of income happening. I mean, it's the startup culture. People love to call themselves entrepreneurs, but if you're broke with a vision of making something different, it will start affecting you eventually. So please always have some backup financing to keep yourself funded while you're working on startups. Um, have a side job, have a side hustle, or have a job and do it as a side job. Do it in partial percentage of your total employment, but always keep having some source of funding. Trust your team members and colleagues. Talk to them about any worries and issues if it comes. Talk to people who can help you build network and bring funding, because my startup journey started as a researcher. I actually didn't know how to raise funding for this kind of commercialization. So having even in Nagoya University, having a person like Sabako-san in the innovation complex, you it will be very nice to talk to people who can help you build network and funding, and search if your technology is worthwhile for commercialization. Attend meetings and lectures that gives you more knowledge on how to build up a company if you're interested. And on the side, of course, keep doing your favorite stuff. So as I said, my journey as an entrepreneur is still going, but I want to pursue my research as a biophysicist. So I moved to Nagoya University, but I still on the side find time to talk to my colleague in Sweden, and we try to build the technique. We hire people. So now we have one person who is managing the project for us in Sweden. My current research is about, again, crystallography and serial crystallization of membrane proteins. And And I'm also working on some unique colored proteins for establishing serial crystallography. And I also use some of these devices that are generated by Serial X to validate and also help my co-researchers to use this technology to gain knowledge from their own projects. And yes, there are a lot of people to thank, but they are mostly from Sweden, and including my professor, laboratory, and students that came and helped and learned experience and went. Padmini, there are always people in the laboratory who help you to buy stuff. We have to be thankful to the people who help you buy these tapes and 3D printing materials and stuff. So we have to be thankful to those also who keep the research going on the side of building the company. And many of these experiments were validated at synchrotrons, and I'm very glad that we have researchers who helped us on time. And there were students from entrepreneurship program from Gothenburg University who also were interested to take it up as one of the summer projects to tell us how to develop a business model. So many of the things as a scientist I learned from the students who were the entrepreneurship and marketing students on how to build startups. And of course, the funding and grants, which are very important to keep the company running, growing, and also uh, eventually the value of the company will be about how much money we eventually made in profits. So we will see. It's still running. 2 years. It's 2 years of Serial X. So it's still going on. And that is how I will end my talk today. Thank you.
Thank you very much.
Thank you very much.
So from the audience, if you have any questions, we can unmute you, or you can put in a chat box or chat book box for the questions. So
Thank you so much for your talk.
Yes.
Well, I think Dr. Swagata is an international researcher with all this experience in India and Sweden and Japan. And also, I think maybe your interdisciplinary research have led you to this great invention. I mean, how do you think math and chemistry and life science have affected your journey?
Yes, of course. Yes, of course. I think um, education, the kind of field I have been in, it has helped me a lot. As I mentioned in my previous first few slides, that this startup was built quickly because I actually had the knowledge of a lot of things
Yes.
about the what we need to build and how it should look like. I put myself in the position of a client or a customer or a researcher who would need this, and then we started building. So I put myself in their shoes, I would say. And internationalization does help because since I have worked in different work environments, it gets easier to open up and talk to people. And in the beginning, we only are focused on our research, but now we want to emphasize, okay, we have to put marketing strategies. You'd say 1 time, 2 times, 5 times, and finally the bosses who are scientists for 25 years get convinced, yes, we have to do it. So persuasive nature. I have developed it through internationalization.
Well, that's a good skill.
Yeah, I mean, it is good that that I have been into, and of course I have been exposed to the environment of startups from quite early. And it was also not, I mean, 20, 30 years ago, it was more about, you know, Silicon Valley technologies, I mean, software ITs. Only 10 to 15 years ago, the biotechnology sector started booming. And even back in India, I would say that I was lucky to be part of that research environment where biotech startups were the biotech startups in our research institute were the first of the biotech startups in India, which means that India only had it in few locations like Bangalore, Delhi, and a place like Hyderabad. And I was in the Bangalore campus, so it makes a lot of it is kind of learning from being there. And many of the startups were actually started by my what do you say, college, I mean graduates of the same year. not experienced, pre-experienced professionals, but graduates of the same year. So I was very enthusiastic to see how is this person going to survive in this startup. But because we have the idea that when you are opening a startup, you have to be kind of no backup funding. I'm starting up, I want to be, I have an idea and I want to start up, but I don't need too much backup funding. But I think there is a nice process, an interesting process to build a startup. And my 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 suggestion would be to figure out if you have that kind of environment around you to build that, the proper funding partner, the coaching partner. I mean, coaching for how to build and how to be resilient in a situation that things are not working and you still make it work. It requires, I think I got good amount of coaching from our one of the team members, that it's okay. So Lorna is a very good business coach. So yeah.
And do you think being involved in a startup from the beginning changed your mindset and make you like realize how startups work and what do you need?
When you said beginning, do you mean beginning of undergrad level or beginning of
After
the
you
startup?
graduated? Yes. And the very first startup you were involved in your slide, you showed that the second part of your slide introducing yourself.
Yes, yeah.
Yeah, this one.
Ah.
The blue slide. Here you mentioned you were a part of a startup already in
Oh, yes.
2016.
So this startup company was C6, is C6. It's still, actually, it's one of the most successful biotech startups back in India. This was built by a few students, then graduate master students from the IIT Chennai. And their idea was to make biofuels from seaweed extract. Okay. And it's a very cost inefficient process. I mean, it's not efficient to make that amount of biofuel from squeezing and drying and pressing seaweed. So the idea is, when they launched the company, they had one vision, but then it diverted into making different kinds of products from seaweed. And I was part of the one where I was making polymer sheets from the seaweed extract. And these polymer sheets could be actually assembled to make something like a face mask or a plastic bag, or some
Like
sort of
natural plastic.
natural, like a replacement of a hydrogel kind of a thing. So I was working, I started very, when I finished my PhD in the final year, I kind of ventured into working with them on setting up a molecular biology lab where we were trying to make these nice polymer sheets. And when I was doing it, I knew that it was not a predefined laboratory with a professor who knows the protocol. It were all us of the same level. So we were reading, we were buying stuff, we were trying to make these things by learning, trial and error. And then we realized after some time, maybe that is also one product, but let's try to venture into another product. One of the things that happens and should usually keeps happening in startup is change of this plan, change of plan. We have to do this, we have to do that. I mean, it was good to do that. Of course, in the beginning, it was hard for me to learn, because researchers, as a PhD researcher, I came from a particular mindset. I'm working on one protein, one structure, my target is that. Now you have to diversify. It gets difficult, but this is what helped me when I stumbled upon making Serial X, that no, we have to keep our mind open. If things are not working, venture into more stuff, What do
Yeah.
people like? Psychology of people. If you are making something commercial, you have to understand the psychology of your customer.
Yes, exactly.
So I think this experience helped me eventually. I mean, from 2017, and we started working on Serial X in 2019.
Yeah.
It was 2 years. In 2 years' time, I kind of used that experience.
Mm.
You know.
I think, yeah, if you want to invent something, commercialize it, then you have to serve customers' needs and adapt to if you are inventing something and then it doesn't work out. You don't stop there. You have to find something else.
Yes, definitely. So, I mean, in this particular talk, my idea to present was also that this is a very small niche in the entire big sector we are talking about.
Yeah.
It's only about trying to accelerate drug discovery by making crystallization platforms.
Yeah.
Uh, but I would say that the process kind of remains same if you are having a big startup to a very small niche startup. The process kind of remains same. Maybe the funding is, you know, is
Yeah.
multiplied several times, and the team is multiplied several times, and the customers are multiplied several times, but the process remains the same. Starts with a good team. We have to start with a good team. We have to make products that could be sold and we have to keep communicating and keep ourselves in reach of our customers. So
That's really nice work.
yeah.
I think also like taking the chance when you see one is really good. Like you saw a problem with the crystallography process, and then you just took the chance to try to solve it. I think it's good.
Yes, and this is when I also spoke about why that one of the challenges is somehow researchers don't tend to shift focus.
Yes.
It comes as a challenge. And when I say here researchers, it was usually maybe not me, but maybe my professors. I mean, what happens is we are so focused on developing something to make, oh, we have to solve some important mechanism of a huge work we are doing with a lot of funding. And when we came up with the idea, which was this was the idea that how about we try to make something gonimeter compatible. So in the beginning, for a few weeks, my professor did not care. I mean, did not really emphasize. But after some time, he tells me, Swagata, regarding your proposition to make something fit with the magnet, can we talk to somebody in the university who can make who can see and validate this for us? It means, can you find out if there is a research and innovation sort of department in Gothenburg University? And first time in I did a search, innovation Gothenburg University research, and I came up with the office, the portfolio of the Gothenburg University venture office, and I just wrote to the support at guv.se. I didn't write to whoever is concerned. I just wrote to somebody, hey, we are researchers, we are doing this. I wrote a long email. I wasn't expecting somebody would reply. In 2 days, a researcher who also has a biochemistry and protein background but switched to entrepreneurship and research, I mean, this kind of academic leadership and research support, she replied to me, and that was Lorna. And she said, oh, how about we try to meet and we discuss this? And I think for us and for them, the best part was we had prototypes ready. We were making these prototypes for our research and not commercialization.
Yes, yes, yes.
How
So
fast you are, like from the idea stage to like actually you start a business?
actually, our idea to business or forming the company was 1.5 years of time.
That's fast.
Yes, but I also want to say that it was easy to pick up because we had prototype products that were validated by our research.
Yeah.
Usually, many of the cases, I think the incubators like it when you have a product ready.
Yeah.
Okay, I think so.
That you're ready to impress them.
I mean, we made the product ready, and what it was is we had this meeting, the first meeting was about, I don't even know what we are pitching. Okay.
Yes.
We just went with professors and I and this Lorna lady Lorna, we sat together and she's like, tell us about your work. And everybody's talking protein crystallography. It's very hard to understand this concept because it's very deep rooted in X-ray physics. But
Yes.
then I presented, see, I have photos of this, and this some of the products look like this. I
Yeah.
mean, I took something like this and this in a bunch of a few plates and a few, I gave a experimental demonstration sort of a thing that this can be plugged to a magnet, see, like this, and we flow the crystals. So we don't know if it is something of of a of something that we can commercialize, or is it even a something valuable for a research community. And then we started discussing about who is your customer, and we said only researchers who use protein crystallography and pharma companies that use protein structures for research. It's like, oh, it's still a big market because there are pharma companies invest a lot on drug discovery. So let's see. So then we went through this procedure of research. We had a person, scientific lawyer, I mean a person with a background in science but also can do some research for us on if this is a product that has any competition or similar products are already there and IPs have been filed, and we found that there was no other competition product, and so we just filed an IP to keep it preserved until we come up with a bunch of other techniques. And then it just picked up. I think every stage of this process motivated us to go to the next stage. And eventually, we had researchers from different synchrotrons who told us, we will not take this product as collaboration, but we will give you, it's better for us if we buy this purchase as a purchase, then we can declare it. For example, this is learning also. In America, many of these national facilities, synchrotron, these X-ray synchrotron facilities, do not accept collaboration products. They only will say, if you have a registered product, we are happy to give you the buy it from you, like pay you the money. So Australian synchrotron and the synchrotron in the US actually didn't want to take as prototypes of the product. They wanted something that they can you put a value and then just give us, you know. So
Yes.
that motivated us to actually register the company a bit faster. And so we can start making some brochures and product sheets and price list. Absolutely, in research we cannot simply sell our thing because this money came from a research grant. So we got the Gothenburg University to spend some funding, and we registered the company, and then we started selling initially in a small scale, but we are now still reaching out to more people. It was good learning process.
Good luck with your company.
Yeah, it's time passed already. So like, we found she studies protein as well,
Yeah.
and she wants to start a business also. She's doing a PhD, so it's a good
Oh,
fit.
I'm actually studying an enzyme, but not
Uh.
crystallography. So this is also new to me.
That's it. I hope we can talk in person someday. And if you, of course, I mean, this was a nice journey for me to share. But if you have something valuable that you can research from, bring from your research, that would be good too. While I think my experience running this company is there are different kinds of biotech startups, and our startup is a product based startup, which is non-perishable material, which means we can always build and we can build and scale up and keep it stocked. And there are also challenges when you are actually making a product that is perishable, like a plasmid, like a protein, like an enzyme, which is very different way of running those, you know.
Yeah.
If somebody asks you, it's an interesting enzyme for some bioremediation process, and you have to maybe make fresh samples for testing
Yeah.
while we can stock up. I mean, I mean,
The process is different. Yeah.
yes.
Okay.
So good luck.
So thank you very much for your time.
Thank you. I hope we meet in person soon.
Yeah. Thank you very much.
Thank you.
Bye bye.